The goal of this short series is a functional system of displays that control the flow of the game and display important information to the player. This video covers the writing of the Level and World classes and the implementation of those classes into a UIManager script that controls the dynamic creation, display, and navigation of the game. The starting point is a simple Angry Birds style puzzle game with no levels, interface, or scoring system. Create two scripts named World and Level. Before we set those up, we're going to jump into the game control script. In here, create a public const int numWorlds, and we're going to have 3 worlds for this tutorial. Then create another public const int named numLevels, and let's say each world has 20 levels. Now create a list of worlds, all worlds, and be sure to right-click on List and import the required library. I'm going to set up the level class first. We need to store private int high score and current score, as well as private bool unlocked. We need some ints to determine the required score for 1 star, 2 star, and 3 stars. Now I'm going to create some helper variables that we don't ever have to set the value of. They'll determine their own value based on the high score. Public bool defeated will return true if the high score is greater than the 1 star requirement. Otherwise, it'll return false. Public int current star score will return 3 if current score is greater than or equal to 3 star rec, 2 if greater than or equal to 2 star rec, 1 if greater than or equal to 1 star rec, and otherwise it'll return 0. Public int high star score will do the same thing except based on the high score instead of the current score. Now create accessors to the private variables by right-clicking on them, going to Refactor, and then encapsulate field and accept. In the constructor, set the high score to 0, current score to 0, unlock to false. I'm also going to set the star requirement values to 10K, 20K, and 30K. Open up World and get rid of the mono behavior. Each world needs a list of levels. Create a private list levels named Levels and give it a public accessor. Create a public int total levels with a get accessor and return GameControl.numLevels. Create a public int total defeated with a get accessor and create a for loop that loops through total levels. Before the loop, create an int count set to 0. Inside the loop, increment the count if levels I is defeated and return count outside of the for loop. Copy total defeated, paste it, change the name to total stars, and in the for loop, increment count by levels I.highStarScore. Copy total stars, paste it, change the name to total score, and change the high star score to high score. Inside the constructor, initialize a new list of levels and use a for loop to add a new level to each spot in our list of levels. Go back to Game Control, and now we can initialize and set up all worlds in the start function. If you play and get any errors at this point, you might want to go back and double check everything we've done so far. In Game Control, make a public world cur world and a public level cur level. These are going to be accessors to the private cur world and cur level. In the cur world, inside a get function, if cur world doesn't equal null, return cur world. Otherwise, make a debug saying can't retrieve current world, values null, and return null. Then inside set, say cur world is equal to value, and make a debug saying current world set. Then I'm going to set up current level the same way. I'll test these out in the start function with random values. Make sure you do this behind the for loop. We're not getting any errors, so we're clear to move on to the UI. Right-click on your hierarchy, go to UI, and then Canvas. Set the render mode to screen space camera, check pixel perfect, drag in the main camera, and then set the plane distance to 5 and the order and layer to 20. Change the UI scale mode in the canvas scaler to scale with screen size. Add a component named UIManager, make sure it's a C# script, and then open it up. We'll start by setting public GameObject variables for prefabs we'll need to pass in. We need container prefab, world button prefab, level button prefab, HUD prefab, and results prefab. Save, go into the UI prefabs folder and drag in the appropriate prefabs. Now create a canvas group array named displays. This array is going to store our world selection display, level selection display, our HUD while playing the game, and our results after beating the game. Then create a GameObject array named world buttons and another named level buttons. None of these need to be public, so I'm going to make them private. Make a HUD GameObject, a results GameObject, and an int current display. The first function I'm going to set up is going to be a utility function that will instantiate and set up UI elements for us. So GameObject init UI element takes in a GameObject prefab and a transform parent. Inside I'll say GameObject temp is equal to instantiate prefab as GameObject and temp.transform.setParent to parent. Then I need to store its rect transform and the rect transform of its prefab, and set the temp rect local position to the prefab rect local position and the temp rect local scale to the prefab rect local scale. Finally, the function will return temp. Make a void function init displays and call it in the start function. Inside of init displays, set the displays equal to new canvas group with 4 slots. We're going to fill out more, but before that we need to make another utility function named initialize items. This one will be able to set up and return an array of UI elements. It's going to take in a GameObject prefab, an int num items, int item width, int item height, int padding, and int columns or calls. GameObject array temp is equal to new GameObject array and set the size to num items. We're going to need some more variables inside of the function. Make an int rows equal to num items divided by calls. Int left inset, and we'll just have it start at the amount of padding, and int top inset also equals padding. Just to give you an idea, inside this function we'll be setting up the container for the items and attaching a canvas group so that it can be added to the displays array. After setting up the container, we'll run through a for loop to set up each individual item inside the container. So jump back up and say GameObject container is equal to init UI element, container prefab, and transform. Add a canvas group component to container, then make a for loop to run through the length of displays. If displays I is null, that means this container should go into that slot and we should break out of the for loop now that we've successfully stored our container inside the displays array. Store the container's rect transform so that we can set the size of the container to hold all of its items. Then containerrect.setSize with current anchors. Let's set the size of the horizontal axis first. Set it to item width plus padding in parentheses times rows. Then set size with current anchors on the vertical axis to item height plus padding times calls. Now this function is nowhere close to finished, but we can start testing it out. Inside init displays, set world buttons equal to initialize items, world button prefab. The number of items is going to be GameControl.numWorlds. The width is 180, height 300, padding 10, and in this case the number of columns is going to be the number of worlds since there's only 3. I noticed I made the mistake of switching up the calls and rows when setting the container size, so fix that and make sure you put init displays into the start function and press play in Unity. So far, so good. Let's pass in a string into initialize items so that we can set the name and title text of the container. Right under where we created the container, add container.name is equal to title and container.getComponentInChildrenText.text is equal to title. Up in init displays, pass in the string worlds. Go into the initialize items function and into the for loop where we're going to create all of our items. Say GameObjectItem is equal to init UIElement prefab container.transform. Then set temp I equal to item, and all three worlds should be instantiating inside of the container. To set the position of each item, make rect_transform_item_rect equal to item.getComponentRect_transform. And then itemRect.set inset and size from parent edge, rect_transform edge left, left inset item width. We have to do this again for rect_transform edge top. Pass in the top inset and the item height. For each loop, the left inset should increment by the item width plus the item padding. Press play and the container isn't quite big enough, so add plus padding to the end of each set size with current anchors function. We actually need to add some space for the title, so make an int title space before int top inset and set it to 50. Then set top inset to title space. Now the title is visible, but the container isn't tall enough, so change the plus padding in the end of the function that sets the height to plus title space. Press play and the container should now be perfectly sized. Now we can use the initialize items function to set up level buttons. Pass in level button prefab, the string levels, GameControl.num levels, width of 75, height of 75, padding of 10, and 5 columns. If you press play, you'll notice we need to implement something to update top inset as well. Back inside initialize items, create an int column count outside of the for loop and set it to 0. Under where we're incrementing left inset, add column count plus plus. Then check if column count is equal to calls, and if that's the case, set calls to 0, increment top inset by the item height plus the padding, and reset left inset back to padding. Press play now and all the buttons should fit neatly into the container. We're now going to start implementing navigation. In the start function, set current display to 0. The world selection should always be the first display we come across. Now make a void function update current. Inside, create a for loop that runs through the length of our displays array. If displays I doesn't equal null, and if I is equal to current display, then its alpha should be 1. Otherwise, its alpha should be 0. Then if we add this function to the update function, it'll make sure only one display is visible at a time. So the way we navigate through our displays is by increasing or decreasing the current display variable. Back in UIManager, make a public void function named click that takes in a button B. This is the function we want to call when any button is clicked. Inside, say if current display is equal to 0, we know a world button was clicked. Else, if current display is equal to 1, we know it was a level button that was clicked. So if current display is 0, we're going to go forward to the next display by incrementing current display by 1. This is also where we're going to set the current world variable that lives in game control. To do this, we need to set up some more variables in the UI manager. Make a private int world index and level index. Then make a public int world index to act as an accessor. When world index or level index is set, we also want to set the current world or current level. So create a private game control named control that'll give us access to current world and current level. Then add control.currentWorld is equal to control.allWorlds world index. Then inside of get, simply return world index. Now copy and paste the world index we just set up, change the name to level index, and set all the values appropriate to the level index. Before we forget, in the start function, set control equal to find objects of type game control. Now we can go back to working on the clicked function. We're given a button, and from that we need to somehow set the world index. Well, if we made sure to set each button's name equal to its position, we can set world index equal to b.name. Cast the name to an int by saying int.parse. Now head to the source of the button inside of initialize items and add item.name is equal to i.toString. Inside of update current, make sure to set block raycast to true if I is equal to current display and to false otherwise, so that the currently displayed buttons respond properly. Since we're creating most of the UI dynamically, we also need to set up how the buttons respond to clicks dynamically. The way I did this was to go inside the init UI element and check if temp had a button attached. If that's the case, store the button as B and say b.onClick.addListener with an empty set of parentheses. Go inside and add another empty set of parentheses followed by an equal sign and then a greater than sign. And next is where you call whatever function you want to be called when the button is clicked. In this case, clicked, and pass in B. Now press play and clicking a world button should take you to the levels display. Let's do the same for the level buttons. Inside the clicked function, if current display is equal to 1, increment current display by 1 and set the level index the same way we set the world index. And now clicking level buttons should take you to the next display, which is nothing at the moment. Back in UI Manager, make a void function called updateDisplayed. Inside, create a switch statement based on current display. If the case is 0, we should update world buttons. If the case is 1, level buttons should be updated, and so on. So let's make another void function named updateWorldButtons. In here, we'll loop through the length of world buttons in order to set up the proper title and information for each button. Text title text is equal to worldbuttons i.transform.findChildTitleText.getComponentText. TitleText.text is equals to world plus i+1.toString. To start testing this out, add update world buttons to case 0 and update displayed into the update function. Next, add text infoText is equal to world buttons i.transform.findChildInfoText.getComponentText. The infoText will display the amount of levels defeated out of the total amount of levels. The total stars.text will display the total stars out of 60, and finally the total score. I'm getting an error here because I didn't set up infoText properly, so I'd find child info panel before find child infoText. \n is a short way to go to the next line, so add that before stars and score. Oh, and here I accidentally said num worlds instead of num levels. Now I'm going to make a function named void update font that finds all text in the scene and sets it to the Angry Birds font. Go up to the prefabs and add public font Angry Birds font. Then inside of update font, create a text array named all text. Set it to find objects of type text. Then, for each text in all text, if text.font doesn't equal Angry Birds font, set its font to Angry Birds font. Then call this update fonts function in the very end of init displays. Back in Unity, find the Angry Birds font in the fonts folder and drag it into the UI Manager. We've got world buttons updating. Let's make another function to update level buttons. Once again, loop through levelbuttons.length and inside the for loop create a text level text equal to levelbuttons i.transform.findChildLevelText.getComponentText. Then set levelText.text equal to i+1.toString. To start testing this, jump into the update displayed function and make sure you add a case 1 and call update level buttons. Next, we need to disable the level buttons whose levels aren't unlocked. In update level buttons, create a game object stars, set it as level buttons i.findChildStars. We're going to check if the level is equal to 0 or if the current level is unlocked. And if that's the case, the stars game object should be set active and the level buttons I should be interactable. Otherwise, both of these values should be false. The stars are still visible because the game object stars is only the container. We need to make another for loop int j to loop through stars children, which are the actual individual golden stars. If the corresponding level's highest star score is greater than j, get the child at index j and set it active. Copy and paste this line above the if check to start each star off as disabled and only enable it if it passes the check. In the next video, we'll add 2 more scripts and continue to work on the UI Manager in order to implement the Game HUD and the results display.